Well, hello, guys. Welcome to lesson number 1 in our virtual class. I'm glad you made it, and let's begin. We're going to talk about probability today, and first and foremost, you will need your math journal today, along with a fresh piece of paper and a pencil. So, we're going to discuss sample spaces today. What is a sample space, and how do we find out how to calculate a sample space? And then we're also going to learn about the counting principle, which is something that we're going to practice in IXL after the lesson. So let's go ahead and get your pencils out. And if you want to, you can put a pause in the video so that you can quickly take down these notes. A sample space basically describes all of the possible outcomes of an event. So when we're talking about probability, an event is an experiment, and we're going to be talking about the results of those experiments and what the outcomes of those experiments are. That's all probability is. So we're also going to learn how to make a list today in lesson 1. We're listing our sample spaces, and then tomorrow in lesson 2, we're going to create a tree diagram. So we're going to spend our first 2 lessons are sample space related. Let's go ahead and I'll tell you what I mean by sample space. So let's just pretend we're at a football game and Baylor and TCU are playing. And we need to think about what are the possible outcomes of that football game. Well, of course, I hope for the possibility that Baylor will win, but of course, there could be another outcome. Baylor could lose. So, the sample space has 2 different options. There's 2 different outcomes that could happen. Baylor wins, Baylor loses, and we just listed them there. Now, let's say that I take a simple die or a number cube, as it's called in this problem, and I roll it. Well, list for me the different options that could happen if I rolled this die. Well, I hope you answered that you could roll a 1 or a 2 or a 3, a 4, a 5, or a 6. So our sample space has a set of numbers that it could roll, 1 through 6. These 2 first examples are simple events. One thing is happening and that we have to keep track of. And then in red on this screen, these are the sample spaces. These are all the possible outcomes that could happen from these events. Now let's up our game just a little bit and talk about a compound event. So this is when 2 things are going on that we have to consider when we're talking about possible outcomes. So here's an example that is real and dear to me, and that's making breakfast for Zeke every day. So every morning when Zeke wakes up, he has 3 options for breakfast. This is a fictional story, by the way. So he could pick from cereal, eggs, or he could have a muffin. These are the 3 foods from which he can choose. Then he can choose from 2 drinks choices. He's got a choice of orange juice or a choice of milk. So every morning, Zeke can pick 1 food and 1 drink. So I want on your piece of paper, I want you to think about what the combination of choices Zeke has for breakfast in the mornings. And you can't pick 2 of any one thing. Okay? So go ahead and do that. Put a pause and make a list of our sample space. Okay, so I hope that you chose, if Zeke picked cereal for breakfast, he would have the choice for cereal and orange juice or cereal and milk. Another option he would have is eggs and orange juice or eggs and milk. If he chose muffins for his food, he could have muffins and orange juice, or he could have muffins and milk. This is the sample space for this situation, and we've made a list of all the possible combinations that Zeke can have for breakfast. Now, I want you to notice something. If you will look over here, he's got 3 options for eating the food, and then he also has 2 drink choices. And if you multiplied 3 times 2, all of the possible outcomes would then equal 6. And you're right, he's got 1, 2, 3, 4, 5, 6 possible outcomes for this event. That, my friends, is the counting principle. So again, pause the video and please write in your math journal what the counting principle is. Go ahead and just put this definition in your notes. I'll read it now. The counting principle is used when you need to find the total number of possible outcomes. You do this, guys, by multiplying the possibilities of one event by the possibilities of the second event, and that's how you get the total number of possible outcomes. So let's work another example together. And this is very timely because you'll be making your schedule soon for the fall, for next year. So if you're registering for classes next year, and let's just say that you have 2 language options. You could pick from Spanish or German. So you have 2 language options. Now, you also have 4 options for electives. You could pick from art, theater, band, or choir. So you can pick 1 language and 1 elective. I want you to create the sample space by making a list of all the possible choices that you could have in your schedule. Put a pause in the video and see what extensive list you can come up with from all the options. Okay, guys, I hope that you came up with, if you first chose Spanish as your language, then you could in fact have Spanish in art, and Spanish in theater, Spanish in band, or you could have Spanish in choir. Let's look at all the options if you chose German for your language. If you chose German for your language, some of the other combinations would be German in art, or you could choose German in theater, or you could have German in band, or you could also have German in choir. These 8 choices here, 1, 2, 3, 4, 5, 6, 7, 8, is your sample space. So you have 8 different possible outcomes from these 2 events. Your language, picking 1 language and 1 elective. You'll also notice that I have 2 languages and 2 electives, so 2 times 4 is 8, and that's exactly how many choices that I had. Now I think you're ready to go on your own and see if you can do this. You'll go to DD14, and it's called Counting Principle. I'm going to work this example. All of your examples look like this. And here's one example. Kylie is choosing silverware with which to eat dinner. She has 5 different knives and 4 different forks. How many different silverware sets can she make? Well, if we take the one event of 5 knives and another event of 4 forks, and we make all the different combinations, we would then come up with 20 silverware sets, because 5 times 4 is 20. Okay, I think that's it. And as always, let's do some math. I'll see you next time.